11T is basically for performance. How do you measure the performance of different things? And so in particular, it defines the metrics for data, latency, application, and streaming media. So you can say, well, for video or for data, what is the delay, what is the throughput, how you measure it. So the latency, delay jitter, packet loss, and the probability of admission, all of these things are defined in that. So this is basically a performance standard which defines these metrics so that everybody measures the same way. Otherwise, everybody will measure a different way, and when you get the equipment from two different vendors, you do not know how to compare this number with that number. So because if you, and there is a trade-off here, because if you increase the path loss, if you allow 10% loss, then throughput goes up, if you call that throughput. So the question is, what is throughput? And then fast BSS transition, receiver sensitivity, association performance, all of these things are measured in that one. So association performance is how long does it take to get associated with the base station. Before you can get associated with the base station, you have to send some things. You have to first authenticate and then, you know, negotiate other parameters. All that takes time. So that is also measured. Receiver sensitivity, if the receiver is very sensitive, then it can get much more throughput at a longer distance. So that is affecting the throughput and all that. So all of this discussion about performance is in that standard. So if you ever need to worry about the performance, you go to that standard 11T. By the way, these letters, some are small and some are big. So 11S, S is little, 11T, T is big. And there is a notation. In all of the IEEE standards, actually, I'm not sure about all the standards, the 802 standards for sure, they follow this, that the little ones are extensions, are enhancements to big ones, so to big ones, yeah. So, for example, little b is an extension to 11, and what they do is, once the 11b is done, that whole document will be merged into 11, and the new 11 document will come out. So there is no standard finally at the end called 11b, because 11b is an enhancement to 11 and it gets merged into 11, right? Whereas the big letters, these standards stay on their own. They are not an enhancement. So this 11T is a standard on performance which will remain separate. So there is another one, for example, 802.1 capital Q, 1 capital D. Those are the examples of standards that stay on their own. Everything which is little goes away. Yeah.
So where does N go?
N is a little.
So where does it go?
11. So basically, after 802.11 N came out, they developed a new version of 802.11-2009 or something that has all the 11N. All right. Now, if you really read the 11N standard when it was being developed, it doesn't have the beginning or the end. It just says change the paragraph number 5 to that, change paragraph number 7 to that. So it just changes. All right. So those little ones are extensions, are enhancements, and they are generally defined as a diff kind of thing, or difference. They just tell you what to change in what paragraph. So they even refer to the section numbers of the original standard. They might even add new chapters. So add chapter 52. But all that will be, after the standard is finished, that will be added to the base standard, and that extension will go away. All right. So for example, if you go and try to find an 11b standard, you won't find it today really, because 11b has been merged to 11.99, whatever here. So a new version of 11 keeps coming out every time little one is done. Clear? All right. 11t. Now we have 11u. And u is little. So this is interworking with external networks. All right. So basically, what happens is you might have an access point, say for example at the airport, and it might supply services with AT&T, Verizon, same access point. One access point providing services for many, many different carriers. In that case, when you come in, you say, well, I'm an AT&T customer, and then I want to go to AT&T, right? So you have to be connected to the right provider, and that is what this standard basically provides. And it might be very simple, small standard. Anyway, it says 11U, so it's an extension which says that these are the two new messages we need. This is a new field we need. This says connect me to provider, and that's it. So those messages are defined in this standard. So allows network selection, checks if the network supports a particular carrier, right? Allows a multiple credential to select a proper one. So now you could be selected, you could have, for example, you could say, well, I can select a T-Mobile and Verizon, one of the two. So you have multiple credentials. One access point can support multiple SSPNs, which is a carrier, a service provider. Clients can determine interworking services before association. And before you associate, you can check that everything is fine, and then an emergency 911 calls. And this allows you to basically make emergency calls. So basically there must be some way to say that this has to go to the 911. So that's the emergency number you dial if you are in an emergency, right? Police number. And many of the cellular companies initially did not provide those services because they were not connected. Now they are required by law not only to be connected to the 911 but also to tell your position. So when you make a call to 911, the operator on the other end knows exactly which location you are calling from. Alright, so that is 11U. 11W is management frame protection. So 11 had big security holes, many security problems, but one of the big problems was that the management frames were not protected. So what is a management frame? Such as disassociate, deauthenticate, or broadcast and multicast, none of these things were protected. So when you hear that Boofy is available, you don't really know whether Boofy is available because it is not protected. There is no way to authenticate that this is Boofy. Alright? In fact, what you could do is, one of the attacks was that you could disassociate, means you could say, well, I am Jain and I want to disassociate now with you. So I'm not going to, don't send me any more packets. So your connection will be disconnected by somebody else. Alright? So this standard fixes that issue. And so it provides data integrity, data authentication, replay protection, and data confidentiality. What is data integrity? Data integrity basically means that nobody can change your data. So if you send something, nobody can change. Yeah, so there are two things which happen. First of all, if W becomes a standard, then it will take 1 or 2 years before it will appear as a product because it has to go through the Wi-Fi. Everybody knows what is Wi-Fi, right? Wi-Fi is the organization. So it has to go through that organization. Once they say, yeah, everybody has to implement it this way, then it will be implemented. And so there is a delay. And after it is implemented, then there are older standards, older products which do not go away. So you cannot even do, for example, at my home, I have some older pre-I devices and some post-I devices. 11I is the security standard. I can't use really post-I because there is one device which will not speak, and I need to speak to that. Right? You cannot just throw away one device simply because it doesn't speak 11I. It's a $300 camera, right? So everything else is speaking pre-I, which means it is not protected. I mean, so that's the kind of thing we run into even any other place, that they might have an expensive piece of equipment which still needs to work, and it still speaks the old ways. Okay. All right. So I was defining data integrity, data authenticity. Okay. Integrity simply means you cannot change the data. Authenticity means it is from the person he is saying it is from. So you cannot just manufacturer and say, well, and this is coming from Jain or somebody else, right? Replay protection. So nobody can everybody can hear your messages, but they cannot replay it. They cannot send it again and be meaningful. Confidentiality means they cannot even read it. So when you send something, it is encrypted. So this is encryption, this is CRC, this is basically authentication, and this means there is some time thing over there so that you cannot replay it later on. Without 11W, attackers can forge disassociation. This was one of the common attacks, is that you could just send a message saying that, okay, I want to go, and then you're gone. Somebody else could say for you, and then you're gone. Broadcast integrity protection, and they use some standards called AES 128 CMAC. The whole thing is a standard name. So that is the encryption standard with which they protect the broadcast. So when you get a broadcast, you know that it is coming from a station, and you can authenticate that. Provides replay protection and forgery protection against insider attacks. So what is an insider attack? Basically, generally the attacks are coming from the outside people, but if you have an employee who wants to do something bad, they could send out something, right? So those are difficult to crack because they are coming from inside. So this has something which protects you from replay and forgery from inside. So only one device that is authenticated, or only people who are authenticated can do it. People who are not authenticated cannot forge it. So anyway, basically 11W is the next level of security after I. 11Y is the contention-based protocol. So we already have contention-based protocol. The 11 is contention-based protocol. All it does is this one opens a new bandwidth, new range. So we have 2.4 and 5 point something. So in middle, FCC has given 3.6 to 3.7. There is about 500 megahertz there. No, 50 megahertz there. 3.65 to 3.70. 50 megahertz. 50 megahertz. The thing about this 50 megahertz is that you cannot use it if the people who have licensed that are using it. So this is kind of conditional use for free. If they are not using it, then you can use it. It's like, this is not actually used for television station, but this is used for FSS and radio location services. FSS, fire security. It could be fire services. Okay. So the thing about the fire services and the radio location services trying to find who is where, these things are not always used. I mean, people have, the fire services have the location in that band, but they don't always use it because they're not always active. So this band can be used when they're not active. So, and in that band, you can use a little bit more power than other devices. You can use 25 watt at the base station and 1 watt at the mobile clients, and that gives you longer range. So basically, you can go much farther than 11, standard 11. Now, having said all this, 11 by, I don't know whether it will really come through, because I mean, it does require extra hardware in some sense, because now you're covering another band. I mean, you cannot work in this band all the time. You are working mostly in 2.4 or 5 point something, but if you find 3 point something available, you use it, and when it is not available, you go back to one of those other bands. Right? So it is at least dual band stuff. Final thing we want to talk about 11 is this CAP, BAP, which was on the list of projects to do. So this problem we have already indicated, a large number of access points people have, and they need to configure routing, security, forwarding. There are so many parameters, and these things are remotely basically located. They are not located in one place, and they are generally located in the ceilings, inside the ceilings, and so on and so forth. So there is a group in IETF. So IETF is the Internet Engineering Task Force. Internet Engineering Task Force, this is the standards body for all the internet protocols. So when you talk about IP, TCP, RTP, any IP protocols, they do it. Everything layer 3 and up, they do it. And so they meet every 3-4 months, and we go to those meetings, and in between 4 months we have lots of emails on each group. They have lots of groups working on different things. So they have a group called CAP-BAP. CAP-BAP is Control and Provisioning of Wireless Access Point. And they started back in 2004 or so, 2005, they came out with the first RFC. So IETF writes the result standards which are called RFCs. And so the first RFC came out in 2005, and they're continuing all the way up to 2009. And so if someone were to take that project, what they will do is they will read all these RFCs, and there are some RFCs which are still in the making, which are called internet drafts. So they will, and all those are available at IETF website. So you take the RFCs and you take the internet drafts, and then you write a summary, basically, paper on that one. All right. So it's working on a common methodology for configuration and for remote provisioning. So basically, you could take anybody's access point and you could configure it sitting at your office. That's the idea. Everybody speaks the same configuration language. So this is more of a management thing than anything else. All right, that brings us to the end of this part of the lecture. So what we have done this part is, first of all, we learned that there are MAC frames have 4 addresses. Let me remind you some things here. So there are 4 addresses. There was a source and destination, SA and DA, and there were 2 more. So there is a transmitter and the receiver. So the transmitter and the receiver don't have to be the source and the destination. Source could be somewhere there. Packet came to me, I am the transmitter. I'm sending it to you, you are the receiver, and then it is destined for somebody else on the other side. Right? So that is 4 addresses. 11E was the standard that provided better QoS. How many classes does it 11E provide? 4 queues. And how did it do that? What was done to SIFs, diffs, and PIFs? Basically, we had 4 sets of numbers.
They have varying lengths depending on priority.
Yeah, depending on the priority, you have different waiting period and different transmission period. That is 11E. 11N improves the throughput. And how does it improve the throughput? By 2 things. Mainly, I had the list of 10 things, by the way, but the 2 main top things are MIMO and channel bonding. What is MIMO? Multiple antennas, right? And what is channel bonding? So you, instead of having 20 megahertz, each channel is 20 megahertz, you use 2 of them, 40 megahertz. Then there are activities going on vehicular communication, fast handover, mesh networks, and so on and so forth, right? So those are the things we talked about. You should go to the library and read, please.